Howdy everyone, my name is Jack Delk, and today we'll be going over how to solve circuits in the S domain that contain op-amps. My partner, Wallace, has prepared two example problems for us, so let's go ahead and jump into it. So in this first problem, we have an input voltage of U of t, which is going to translate in the S domain to a voltage of 1 over S. And then the two resistors are going to directly translate to a 10 ohm impedance and a 100 ohm impedance. And we have two input terminals to the op amp. So we have our VI and our VN. And with op amps, the VI must equal VN. And in this case, VN equals 0. So VI will also equal 0 because it is also an inverting op amp, just to take note. So we will begin by solving using nodal analysis at VI. So we get VI minus the input voltage of 1 over S divided by 10 plus VI minus Vout divided by 100 ohms equals 0. We know that VI is equal to 0. So we will simplify this down and get 1 over S divided by 10 plus negative V naught over 100 equals 0. We can now solve for just V out and multiply everything by 100. So we will get that V out equals negative 10 over S. And then if we translate that back into time domain, we will get negative 10 U of t volts. And this makes sense because we have an inverting op amp with a gain of 10, so negative 10 U of t is a reasonable answer. Now let's move on to a little bit more complicated of a problem. So again, we are solving for V out, and we are going to assume no initial conditions since we have inductors and capacitors, just to make it a little easy on ourselves. We have an input voltage of 4 e to the negative 2t U of t volts. And so let's begin by converting everything to the S domain. So first, the input voltage gets converted into 4 over S plus 2 volts. The 10 ohm resistor becomes a 10 ohm impedance. The 1 Henry inductor converts to L times S. In this case, L is 1. So we just have an impedance of S. And then our capacitance in the S domain is 1 over CS, which in this case is going to translate to 5 over S ohm impedance. And again, because this is a op amp, so the input terminals of the op amp must equal each other. So in this case, VN equals VI and VI equals 0. So now let's look at our nodal analysis as we solve for V out. So we're going to be looking at the VN node. So we get VN minus the input voltage of 4 over S plus 2 divided by 10 plus VN minus V out over S plus VN minus V out over 5 over S. And all that is set equal to 0. And remember, Vn equals 0. So we can cancel all those out when we're simplifying. So let's go ahead and move V out to the other side. And this is going to be V out times 1 over S plus S over 5. And that is all equal to negative 4 over 10 times S plus 2. We can now divide the V outside to the other side. So V out equals negative, let's go ahead and simplify this. So negative 2/5 times S plus 2. And then all that divided by 1 over S plus S over 5. Let's go ahead and simplify this out. So we will get V out equals negative 2 times 5. And then we can do some distributive property here. So we will get 1 plus S squared over 5 plus 2 over S and then plus 2s over 5. Sorry, the s's and 5's look very similar to each other, but make sure you don't get them mixed up with each other. I'll go ahead and fix that just a little bit. This should be 2 over s. So now let's distribute this 5 out. So we get v naught equals negative 2 all over 5 plus s squared plus 10 over s plus 2s. So now let's multiply top and bottom by s. So I get v out equals negative 2s over s cubed plus 2s squared plus 5s plus 10. This can then be factored out to be equaling negative 2s divided by s squared times s plus 2 plus 5 times s plus 2. And then this equals negative 2s over s squared plus 5 times s plus 2. And so now we're going to have to solve this using partial fraction decomposition. So we can rewrite this as a to the s, or as plus b over s squared plus 5 plus c over s plus 2. And this is a little bit of a difficult partial fraction decomposition. So I went ahead and solved it right here. So feel free to pause the video and look over this. But at the end of it, you should find that a is equal to negative 4/9, b equals negative 10/9, and c is equal to 4/9. And so you get a resulting of this, which is v naught equals negative 4/9 times s over s squared plus 5 minus 10 over 9 times square root of 5 times square root of 5 over s squared plus 5 plus 4/9 plus 1 over s plus 2. And so let's convert this back into the time domain. So s over s squared plus 5, that's going to translate into a cosine. So we're going to get negative 4/9, negative 4/9 cosine square root of 5t minus, and so the next one we have a square root of 5 over s squared plus 5, so that's going to be a sine. So 10 over 9 square root of 5 sine of square root of 5t. And then for the final term, we have a 1 over s plus 2. So that is just going to be a exponential. So this is going to be plus 4/9 times e to the negative 2t, and all of that times u of t volts. And so this will be our final answer. Thank you very much for watching and listening, and hopefully you were able to follow along, and good luck with future problems.